scales and sludges, right? If the boiler feed water is treated properly, this PPT formation can be avoided or it can be minimized, or the PPT forming body will form less harmful, loose and soft precipitate which can be easily removed by brushing the boiler part or the pipes or by scraping, isn't it? This prevention involves actually two different operations. One is, so the prevention part can be studied under two headings. First is external treatment. First is external treatment. That is external treatment of boiler feed water. Okay. And second can be grouped as internal treatments. Internal treatments. Okay. The name itself indicates before feeding the water to the boiler for generation of steam, what treatment we are going to carry out. So it is external treatment. It mainly involves two operations. Let us avoid contamination and let us use softened water, or let us treat the water by say zeolite process or by ion exchange process. Okay, make it soft and feed it to the boiler, even maybe by soda lime process. So these are the external treatment. In our syllabus already two methods we have seen, that is zeolite method of water softening and second is ion exchange process. Second is ion exchange process. As far as exam is concerned, short note for 6 marks, short note for 6 marks. This may be numerical for 3 to 4 marks. बरोबर चाललंय? काही problem नाही. Okay. Now here will external treatment is already covered. We'll go to the internal treatments. Fine. On feeding water to the boiler, what are the treatments we are going to carry out? What treatments in a boiler plant actually carried? These are called internal treatments. These are so many treatments, 3-4 treatments we will see here which are required in our syllabus. First is called collateral conditioning. Some conditioning we are doing. Collateral conditioning, isn't it? First treatment is collateral conditioning. Okay. In internal treatments, so many treatments are carried during the process in a boiler. Here we will see 3 to 4 internal treatments. First is collateral conditioning. What is meaning of this? Some gel-like substances, some oily substances we are adding in a boiler. It may be kerosene even. It may be kerosene, or it may be tannin, or it may be agar-agar. Okay, these are say oily substances, gel-like substances. If this is my precipitate, if this is my fine PPT, like this tannin, agar-agar, they forms a sort of blanket. They forms a sort of coating over the sticky precipitate. Maybe of sulfates, maybe of say carbonates, and make it soft, make it loosely held, make it slimy, so that this PPT can be easily removed by brushing the boiler part or by scraping or even by blowing air, called blow down operation. So this is one simple treatment that is called collateral conditioning. Second is Calcon conditioning. Calcon conditioning. C-O-N-D-I-T-I-O-N-I-N-G. Calcon conditioning. What is this Calcon? Formula of this is, it is NaPO3/6. It is sodium hexametaphosphate. Name of this is sodium hexametaphosphate. This is Calcon. Okay, we are going for Calcon conditioning. Now if you look at the structure of this or unit of this Calcon or sodium hexametaphosphate, actually it is like this. It will be twice Na plus in a outer sphere we can say, and it will be Na4 P6O18. This is inner sphere. In a square bracket, one part is there. That is the way we put the complexes, isn't it? So the square bracket component is an inner sphere and Na plus in a outer sphere. So when you treat water which is containing soluble salts going to form a residue as a scales or sludge, this Calcon, this unit forms a soluble complex with calcium ions, with magnesium ions, which are the residue forming body, which are the PPT forming body, which are the scales and sludge forming material, and these ions will remain in a soluble form as a complex, isn't it? So there is no formation of precipitate. That is Calcon conditioning. What is the reaction? See, one reaction we will see. Calcium sulfate. Okay, this is there in my water that I have fed it to boiler. This is a very dense and hard PPT forming substance. When I am reacting this with sodium hexametaphosphate, so it will be Na4 P6O18 2 minus what is the reaction? The reaction will be, this takes the scale forming material, it will take calcium. Okay, it will be okay. For example, so suppose my water, see, the water containing, say, suppose calcium sulfate, it is going to form the dense and sticky precipitate hard PPT. This calcium sulfate is there, suppose in a soluble form in a boiler feed water. When I am giving treatment to the water by Calcon, it will be Na4 P6O18 2 minus. Okay, so this will be twice calcium sulfate. This forms a soluble complex with calcium ions. Reaction will be Ca2 P6O18 2 minus as it is to balance this outer sphere, and it will be Na2SO4. It will be Na2SO4. It will be twice Na2SO4. Fine, it is correct. Now this is in a soluble form. This is a soluble complex. This is soluble complex. Okay, so the PPT forming calcium ions or magnesium ions will remain a part of soluble complex. It will not come out in the form of precipitate. That is called as Calcon conditioning. Okay, one more is very familiar to you, that is already we have seen. It is called as EDTA conditioning. It is called as EDTA conditioning. We have seen a separate short note on this. What is EDTA? It is a chelating agent. It is an example of hexadentate ligand. So when you add this EDTA to the boiler feed water, role of EDTA is it forms a complex. It forms a complex with hardness causing calcium and magnesium ions, so that this PPT forming or scale forming substance remain in a soluble form. This is a soluble complex. This is a soluble complex. This way soluble. This is soluble. This is soluble complex. EDTA forms a soluble complex. We know that, so that the PPT forming substance will remain in a soluble form. This is called as EDTA conditioning, isn't it? And fourth point is it is carbonate conditioning. Carbonate conditioning. Certain carbonates we are adding, different carbonates we are adding to water. See one reaction. it is sodium carbonate, Na2CO3, that is soda. Okay, when you add to water, boiler feed water containing suppose calcium sulfate, okay, so this is a very strong adherent, very hard and sticky PPT forming salt. Okay, we can convert these to less harmful PPT forming substance by reaction with soda or by reaction with sodium carbonate. Simple reaction you can easily write. I will get here CaCO3, that is less harmful, plus Na2SO4. This is the one reaction for carbonate conditioning. Different carbonates we are adding. Okay, and so this is one is the fourth. One reaction is sufficient. So one reaction for carbonate, one reaction for colloidal, one reaction for what is that? One reaction for phosphate. See the one reaction for EDTA. You can write reaction for EDTA, and lastly it is a phosphate conditioning. It is phosphate conditioning. In a high pressure boiler, we add different phosphate, sodium phosphate, or these are orthophosphate, sodium hydrogen phosphates. They react with the hardness causing substance, or more, they react with the PPT forming substance, which is a hard and dense, and convert to less harmful PPT forming substance, isn't it? So in a high pressure boiler, we carry out phosphate conditioning. For example, 3CaCl2 plus twice Na3PO4, that is sodium phosphate. Thrice CaCl2 plus thrice Na2PO4, this is orthophosphate, or it is sodium phosphate. Fine. This is there in a boiler feed water. What I am getting? I am getting Ca3PO4 by 2 in the form of PPT, but that is less harmful, plus it is 6 NaCl. It is 6 NaCl, isn't it? So this is sodium phosphate. Different types of phosphate we are adding. In a high pressure boiler, idea is that let us convert the scale forming substance to sludge forming substance, isn't it? This is one reaction. Second reaction, it is CaCl2, which is there in a boiler feed water. Now we are adding orthophosphate, but not sodium phosphate. It will be Na2HPO4. We will be adding Na2HPO4, that is sodium hydrogen phosphate. Okay, CaCl2 in water, adding orthophosphate, it will again form. This will be thrice CaCl2, it will be twice Na2HPO4. I am getting Ca3PO4 by 2 in the form of less harmful substance. So conversion of these to this, isn't it? Plus what? It will be 4 NaCl plus twice HCl. Okay, these are the reactions. These are the reactions coming under heading phosphate conditioning. Okay, I hope this much is. So these will be 4-5 points: colloidal conditioning, carbonate conditioning, Calcon conditioning, EDTA conditioning, and phosphate conditioning. This is point number 5. So this will be the 4 mark short notes, in which 4-5 reactions should be the part of answer. Okay, I hope you have understood this. Okay.